What we have here is a 500 watt audio amplifier. Not many controls apart from an on-off switch and a LED indicator. On the back we've got cannons, RCAs and TRS in and out. This is for looping the audio through to another amplifier in the chain if you've got a big system. The output's got 8 ohms and a 100 volt line, and big PA systems of course use 100 volt line systems to reduce the loss in level on long lines to all their loudspeakers, and they balance out the speakers with transformers at the end. So that's the way to do it professionally. There's also a speech only, maybe there's a filter in there to cut out the bass. Of course big horn speakers don't like a lot of bass in them. It can be run on mains power, and also as a backup it will also run on 24 volts DC. This is a bit more modernity than most of the things we look at, but it's still very impressive. There's the toroid mains transformer, power supply and preamplifier board looks like. The rectifier with the bridge diodes. 10 big power transistors mounted on each side of this heatsink. The big heatsink in the middle seems to be a hollow affair with fins in the middle and a fan blowing through to keep these power transistors cool. One of the problems with these sort of PA amplifiers is the transformer, because to get the 100 volt line impedance you need, which is about 200 ohms, you need a transformer, and I think the 8 ohms comes from the transformer as well, so there's often some compromises in those transformers. That's not a very big transformer for 500 watts, that's for sure, but sometimes they're a bit funny on the bass, they go distorted or don't have much bass at all, but we'll find out. We'll do a test. The impedance straight from the transistors should be low impedance. You should be able to run speakers directly from there if you wanted to. But we'll try it out. At least having the transformer gives some protection to the transistors. Of course, it's totally isolated electrically, and any shorts or funny impedances tend to be ironed out a bit there and doesn't wreck the transistors. Although this has got protection, and any overloads or whatever would it just turns off. Power it on and see what happens. Oh, the lights blink, and there's quite a noisy fan. You need about 100 watts to hear anything over it. It's probably meant to be in a rack somewhere in a dark room. Well, we'll put some tone in there. About 400 hertz. Oh well, the speakers popped already. I think I need a more sophisticated way to test out this amplifier. It's just too powerful. Just made up a little network here, a couple of 100 ohm resistors. They're 100 watts, so they should last a little while. And that gives 200 ohms in series, and the speaker is tapped across a little bit of it, so it only gets, you know, a fraction of or maybe a watt or something, so it won't pop so easily. So now we can do some tests and see how it really works. Okay, that's at 400 hertz. We'll wind it up a bit, see what happens. Starting to clip there. If I measure the voltage, I can do the formula and work out how many watts it is. Starting to clip. The ear is a very good indicator of clipping. It's pulling 0.8 amps of, at 240 volts. I think it's running pretty close to 500 watts output. We'll do some frequency response tests. That's 400 Hertz. A kilohertz, 1.5. 2K. 3 kilohertz. 5. We'll adjust the trace. There's 5 kilohertz. 10. It's going well. 15. That's 20 kilohertz. It's if I go from 20 to 2, not much difference. K, 2 kilohertz. Okay, there's 20 kilohertz when you say hello to the bats. 20 kilohertz we'll switch it down to 2 kilohertz and get the same voltage, same scale. Well, it's not too bad, is it? It's pretty flat to 20 kilohertz. Back to 400. Now the low end might be interesting. That's I'll just get a reference here. That'll do. 400 hertz. 200 is looking okay. Let's see what happens here. 100 Hertzian waves, 100 Hertz, .50 Hertz is looking okay. But it doesn't seem to be wrecking. It's running about 200 watts. The resistors are smoking a little bit. Anyway, that's 200 watts at 50 Hertz. 40, 35, 30 Hertz. Not bad for that transformer. 30, 25. Oh, it's packing. Oops, turned itself off. It obviously doesn't like anything below about 30 Hertz. The transformer's obviously, the magnetic construction isn't good enough for that. But it's not too bad. I'm not complaining. It's pretty flat from 30 Hertz to 20K. And that's pretty good for an amplifier like this.
Giuseppe and Philip welcome you to the Little Wireless program. Big night tonight, Rio Tinto and the Guinea payment scandal.
So we're actually pulling the mains with audio.
And, what John Howard forgets to mention when he's eulogising Sir Robert Menzies, issues of Bob and his attitude to Rhodesia and apartheid.
Well, I guess everyone wants to see a speaker pop, so here we go. See, it's not very spectacular. Just the coil burns out. There's a smell of burning speaker cone or coil. Yep. There we are.